In this video, we'll continue our discussion on class members by taking a look at a very important one, and that's methods. Now, if you've been following along through Volume 1 and Volume 2 of the XNA Xtreme class, you should have a pretty good grasp on what methods are. Basically, it's within methods that we'll find the true behavior or functionality that we give to our classes. Now, up to this point, we've never had a true formal introduction to methods, so that's what we're going to do here. Plus, as we work our way through this video, you're going to find that there's some concepts that have not yet been covered that are very handy. First, before getting started, let's go ahead and point out the 7 key concepts that I want you to grasp by the end of this video. If you understand all of these, you're going to have a really good idea of what methods are and what they can do for you. They're going to start out with, obviously, the most important is, what are methods? From there, we're going to move into syntax. Syntax breaks down into 2 different things here. We're going to look at method syntax and parameter syntax. Next thing we're going to look at is going to be calling methods or method calling. This section is actually going to be really important to me. And the reason is, a lot of people out there that are new, getting into the world of programming, they get introduced to methods, procedures, functions, whatever you want to call it, depending on what language you may have come from. And I see these beginners get really confused on the concept of, if you call this method, and then from inside this method we make another method call, and then from there another method call. And within these methods we have local variables, and those variables come into scope and they go out of scope. And for beginners, this becomes really confusing. So in the method calling section of this video, what I'd like to do is trace through like 3 different methods that are interacting with one another and show you what's actually happening in your computer. Now, of course, I'm going to generalize it, because if we get very specific, it will become, well, somewhat complex. But we'll keep it simple, and we're going to show you basically what's taking place on the stack as we're working our way through different methods. We're going to see how stack frames get created, basically how they exist within the moment of dealing with that class, and then how they get erased more or less as the stack is unwound and we return back to a calling method. So this should be an interesting section for anyone out there that still has a bit of trouble understanding what's taking place with methods. By the time we get to the end of this section, you should have a really clear understanding. But there's more. After this, we're then going to talk about method terminology. I'm going to go ahead and cover a few things that you may hear out there in the professional world, things like the method header, the method signature, the argument signature, etc. From there, the next thing we're going to take a look at is going to be modifiers. And I'll try to keep this as quick as possible, because we have beat modifiers to death, more or less, if you think about it. We've covered public, private, protected, all that good stuff over and over. So we'll talk about it here, but again, we'll keep it really short. If you need any type of refresher on it, just go back and watch the fields video right before this video here. After modifiers, the next thing we're going to talk about is parameter passing. And this is going to be really interesting, because at this point we'll have already seen parameter passing, but what we're going to do is we're going to talk about it in a different light. We're going to look at how we pass rather by value, or excuse me, by value. Just wanted to get ahead of myself there. Or by reference. And I've got to be really careful when we get into this section, because it will be very, very easy to confuse a beginner, because at this point you may understand value type and reference type. Now we're going to talk about passing by value and by reference, and it really does mean 2 different things. So we got to make sure that you have a clear understanding as to what's going on. You may have a value type that you're going to pass to a method by reference, and you may have a reference type, an object that you pass. Well, you could pass by value or by reference. So we're going to take a very close look at this with several examples. And then to wrap everything up, we're going to introduce a new concept, which is very cool. It's called method overloading. Method overloading. This is where we actually have the ability to have multiple methods that exist with different signatures, and they can exist within the same scope. We're going to talk about this, but it's a very powerful concept that allows us to do some really neat things. So that is the 7 key concepts that I would like for you to walk away from this video understanding. So we've got a lot of work in front of us. Let's go ahead and get started. First of all, what is a method? Well, here's a definition for you. A method is a code block containing a series of statements in C#. Every executed instruction is done so in the context of a method. Now let me see if I can give it to you in layman's terms. A method is a way for us to take code and package it up nice and neat. So I can put a whole bunch of code in here, and this code is related to some sort of task. And we can package it up within the method construct, if you will, and give it a name. Like, for instance, something I used to use back in the days of teaching programming at an institution. You used to talk about washing dishes. Do you remember that, Logan?
I do.
So back in those days, I used to tell people, my daughter, if I was to tell my daughter to go wash dishes, I have just performed a method call. I have simply called upon the method. Well, first of all, we could say my daughter being the object, and then the behavior, wash dishes. And what does she do? Well, she goes and performs the task. She runs water in the sink, she puts the soap in, she puts the dishes in, she does her thing, and then when she's done, she lets me know, okay, I'm done. So now it's back to me, and I can go and tell someone else to do something else, or I can tell her to do something else. But it is a task that she has learned how to do. She's been equipped with performing this task, a behavior that she has, and it is known as wash dishes. Now, I don't have to pass her any parameters, so I can just do an open and a closing parentheses. But that is the whole idea of a method. It is basically the encapsulation of some sort of behavior in the method itself. Anything you want to add to that, Logan?
Or another way to look at it is it's a group of individual actions, or statements if you're talking in code, that can be referred to by a single name. When you call upon wash dishes, you don't specify which utensils to wash, what soap to use, what order to do all those things in. You just say wash dishes.
That's right.
And you expect a series of things to occur.
Precisely. And these single statements that you're talking about are things like turn water on. That would be a statement if we want to really kind of just give the analogy a little bit more life here. Add soap. Next statement. Put dish in. Next statement. So on and so. So you could have a loop right there, right? 4i equals 1 to number of dishes. And then inside the loop, put dish in sink. And then you just loop through all the dishes. Okay, we're having too much fun with the analogy. But that is the idea of a method. So you're wanting to put behavior inside of, it's almost like a little container in a way. So, and you've seen these as we have been working our way through the different games in Volume 1 and some of the different examples we've been giving here in Volume 2. So as we work our way through this video, we'll give several different examples. Now, a very easy one, let's say that we had something like add numbers. If I was to come in here and create something like public int add num, just so I don't have to write out quite so much. And add number is going to take in some parameters such as an int num1 and int num2.
The M on your add num isn't an M.
Where
on the add num?
I was just checking to make sure you pay attention. There you go. Thank you very much. Add none. Yeah, okay, that just doesn't really work here. Add num does. Okay, so the idea of this method would be to add these two numbers together. So we could go ahead and come in here, open parentheses, closing parentheses, and then we would add our code inside. Let's fix that up a little bit. And now the code inside, we're going to have to make sure we return a value because we're saying so here in the definition of this particular method. So we could just go in and say return num1 plus num2. Terminator. Very simple, right? So here we are. We have created, here's our little package, if you will. And then here is a statement where Logan said you're going to have multiple statements that exist inside of a method. Well, here's an example of a single statement.
Right. Well, like I was saying, you can have multiple. Of course, you can have just one. You can have however many statements you want inside of a method.
That's right. Now, of course, the idea is to make sure it's all related for performing a specific task. You don't want to just go throwing a whole bunch of code in here that's doing a whole bunch of unrelated things. The moment you end up with a lot of code, you might want to reconsider exactly what's taking place inside your code and try to further break it up.
Otherwise, the code will start to become very unmanageable.
Exactly.
Because if you have a method doing a lot of things it's not supposed to be doing, suddenly something like add numbers formats your hard drive.
Precisely.
That would be greatly undesired.
Exactly. Yeah, very much so. Okay, so here's an example of a very simple method. So as long as you understand that the idea of a method is a place where you can put behavior, functionality, statements, okay? Now, let's go ahead and move down to syntax. So for syntax, it's really pretty straightforward. We're going to have modifiers. Again, this is simple syntax. I'm leaving out attributes. So return type. Our identifier. Opening parentheses. And then inside here, and it's optional, is going to be what is referred to as our formal parameter list. And let's go ahead and close that off. Okay, then open and closing curly braces. And then our method body, our code, is going to be between those. Now, let me go ahead and erase that little line out that I just drew, because I wrote this right above just to show you how this does translate to the real world. So, modifier, return type, the identifier, what we know the method as, its name, and then the optional formal parameter list exists right here. There's our list. We've got, in this particular case, 2 different parameters that we're sending in. Then, of course, we've got our opening and our closing curly braces and our code, finally, inside the method itself. Okay?
One thing to point out here is that the return type is required.
That's right. It is not optional. You do not see the opening and closing square brackets. If you did not have a particular return type, we would use void.
That's right. That's why we've been using void on methods that don't need to return a value.
That's right.
Because the syntax specifies that the return type is not optional. You have to have a return type.
Precisely. Now, so that's the syntax for method. But there's also, so let me go ahead and bring our attention back up here. So method syntax, we just looked at that. But there's also parameter syntax. As you can see, well, I've got parameters down here. Let me find a place I can write this. Well, I can just squeeze it on over here. So basically, what we have for parameter syntax is modifier, type, and identifier. Now, modifier in this particular case, you can see it is optional. It has the open and closing square brackets around it, and we are not using any modifiers in this very simple example that I just threw up. Don't worry, we'll be talking about the modifiers full parameters as we progress into this video. Now, type. We are indeed using type. You'll notice there are no open and closing square brackets, meaning that if you're going to have a parameter, you must have the type specified. And, of course, the identifier, the name that we are going to refer to this parameter as inside the method itself. So this is the syntax right here for parameters. And this up here, that entire thing, is our method syntax. Oh, this is all too easy, Logan. So let's see. That means we've taken care of what are methods. We've taken a look at syntax. Ooh, method calling. Yeah. All right, everybody get comfortable, because this is where it gets to be a little bit of fun. So let's go ahead and come in here for a moment. And feel free to fast forward. This, again, we're in a situation where I am just going to talk and have fun with it, and hopefully some of you guys will have fun with this and just get a lot out of what's being shown here. And if you have a good understanding as to what's going on, feel free to fast forward. That's the beautiful thing about having that track bar down there. All right, so let's write something out. So we'll start out with Yeah, you definitely may want to fast forward this because I'm just going to do a bunch of writing for a minute. So static void main open parent, and I'm blah parameters. Okay, I'm simplifying now. And inside here, what are we going to have? Let's have int a, and int a is going to be initialized to a value of 5. Next, we shall have int b. Integer b will contain 6. From there, let's see, we'll go ahead and throw in, a total. So int total. Boy, my writing is awful tonight. Hang on one second. Let me find something, there we go, that I can use to block. See, what I'm hitting, guys, is my Wacom tablet. I'm hitting the edge of this here, and it's wanting to cause difficulty. Okay, much better. Okay, so int total, and total is going to be equal to the results of a method that I'm going to write in a second called add num. Oh, what do you know? We're going to use what we just saw on the other page. Excellent. And we need to send add num a and b. And, of course, we'll end the line off with a terminator. All right, from there, let's go ahead and just do something like, now remember, when I do this, the comment marks right here, it's just substitute, if we were coding this for real, the console.writeLine, yada, yada, yada. So write, so we're going to do a console.writeLine, something along the lines of total equals, and we'll append to that total. And terminator. Okay, so that is the one method. Now let's go ahead and create, since this whole thing is going to exist all together, static int add num and then its formal parameter list int num1, comma, int num2. Now, when we introduced the formal parameter list a minute ago, I didn't actually draw it into the syntax, but the list with each item that you place in there, each parameter, they're simply separated with a comma. You have to have a comma separating them, so keep that in mind. Okay, so now let's go ahead and drop on down here, and inside here, what are we going to do? We're going to do int total equals num1 plus num2. Then we're going to come down and we're going to call another method. We're going to call show double. And we'll define this other method in just a second, but show double is going to take in an integer. So we'll send it total. And then finally, we're going to return total. And terminator. All right, we're almost done. Again, for those of you who don't like to wait around, you have that track bar. Please make use of it. So finally, static void, and that's a case where we're not actually going to be returning something back, as Logan was pointing out a minute ago. So void, and then show double. And as I said, show double is going to take in a single integer, and we'll just call it num. Okay? And let's go ahead and do something inside here. Let's make it a little more interesting. Let's create an integer called doubled. And doubled is going to be equal to num times 2. And this, we'll just, since the whole idea of this method is to show doubled, we'll write out something like doubled equals, and then we'll just append to that. That is an equals, I promise. We'll append to that the variable doubled. And terminator, and then that we'll wrap up that method. Okay, so we have 3 different methods here. So what we want to do is take a look at what's going to happen on the stack as these methods get called. Now again, this is generalized, but it is a really good generalization of what's taking place. So this should give you a really good idea. So here we are, we're over in the stack thread right now, and the first thing that we're going to do is start out, here's my stack, I'm going to make real quick. Variables that we have the variable A, so basically we're starting execution right here. You know, the first thing that's going to happen is we've talked about this already, what happens when a method gets executed, the first thing that's going to happen is with the code it's going to go through, it's going to go ahead and declare all of our variables. So on the stack, we get A, which is going to be a value type, so it's actually going to store the value 5 in it. I'm kind of skipping ahead because all these variables, of course, get created, initialized to 0. Then we go back and everything gets set. B is going to be set to 6. A variable called total is created. Okay, that should be enough room for the stack as we work our way down. Now total at the moment is assigned to 0, of course, because we don't have anything to directly initialize it with. So we've now worked our way down. We've set A to 5, execution pointer. Now we've set B to 6. Now down here at total, we do a call to the method add num. That means we are calling upon this method right here. Okay. So with that, let me see if I can actually back up. I got an idea, Logan. This might help just a little bit if I was to come over here and bring up tools and switch my color. What do you think? Maybe it'll keep it a little bit clearer. Maybe not. We'll see. Okay, so now we're making a call down to here. So what takes place? Well, the first thing that's going to happen is we're going to look at what's to be expected. Over here, we have got 2 different parameters. So the first thing that's going to happen is over here is our parameters. We're going to get parameter num1, num2, and a return address. Now you may be thinking to yourself, a return address, and it's kind of odd that you've put the parameters first. Well, this is just how it works. The return address is basically going to tell us where we need to set our execution pointer back. We need to know after we are done with this method right here, what's going to happen? Where are we going to go? We need to return back to where we called from. So I'm going to go ahead and bring my tools. I'm going to leave them up right over on the other side. This will make doing this whole thing with color a little bit simpler. Okay, there we go. So now as we work our way through, we're now down into this new method. Now, a quick scan through the new method. Again, every time we run a method, the first thing that's going to happen is we're going to get a pass-through, and we're going to go ahead and declare and initialize all of our local variables. So what is a local variable? Because remember, num1 and num2, these guys right here are what? They're parameters. Now our local variables down here, well, we have total, so let's go ahead and come over here, and total gets created. And initialized to 0, but I'm not going to write that there at the moment. Let's go ahead and, well, all right, fine. I'll write it there. There, I feel better. Okay, so we've got 0 in there. Now we're ready to pass the information into num1 and num2. So num1, this is so key. You really need to understand this. Remember, right here, we're passing A and B. We're passing a copy of A and B. And this is going to become really important shortly in this video when we start talking about passing by value and passing by reference. But you can see it here. We're actually sending a copy. So A contains what? It currently contains a 5. So a copy of this information is going to be placed down here into num1. So num1 gets set to equal 5, and B contains what? B contains 6. That's going to get copied down here. So num2 contains 6. So it's a 1 for 1. So we've got one argument, another argument goes into first argument, second argument, okay? So if you had a list of 5 things, you better send 5 things. And the order in which those 5 things are sent is, well, it's basically put into the slots in the way they're received. That's why A is into num1 and B goes into num2. All right, very good. So now we've got 5 and 6, and we're ready to rock inside the add num method. Now let me go ahead and point this out. This right here is a stack frame. That is the stack frame for our main method at the moment. Now we've got a new stack frame for the add num method. So all of our local variables are going to exist inside here. And this is really going to help make clear scope of local variables, because you're going to see how they're going to get erased in just a minute. Okay, so total equals 0. Now our execution pointer, we start right here. Okay, so total has, of course, been declared. So what are we going to do? Well, we're going to take num1 and num2 and add them together, which is going to give us a value of 11, and that gets stored into total. So now total becomes updated with a value of 11. Now what are we going to do? Well, we come down to the next statement. And in the next statement, it is a method call to show double. Well, show double does what? It takes in one argument, right? So that means we're going to need to go ahead and come down here once again. Let's see. This time around, Logan, let's change colors. I'll make it quick. Dun, dun, dun. All right. So again, we need to come down here and set up our parameters first. So we've got num is what we've called it. So num. And actually, you know what? My apologies, guys. Let's scoot num over just a little bit so we have a little bit of room. Once again, that's this guy. All right? And then we're going to get a return address. What is return address for? Again, it's going to let us know, as far as execution goes, that once this method gets complete, so once we've reached the very end, where was our caller? Where do we need to return back to so that we can continue execution in the calling method? That's the key thing here. Okay, so now, of course, num's been created, initialized to 0. We've got our return address. Now, we need to go ahead and declare any local variables inside show double. So we do have one. We've got doubled. And it gets initialized to 0. That would be doubled right here. Okay, actually, that is about a horrible line. And that's about 100 times better. Now we have a new stack frame. For show double. Again, a very generalized look at what's happening in memory on your stack. Okay, so fantastic. Now we come down here and we begin our true execution in the method itself, starting with our first statement. First statement says that doubled equals whatever is in num times 2. Well, of course, the value did get pushed over into num. So when we called it, what did we send to it? We sent total. So what was in total at the moment? Total's right here, 11. So what happens? A copy of 11 is in num because it got passed into the parameter. So now when we say num times 2, we're working inside our stack frame at the moment. So here we go. Inside here, num is 11, and if we multiply that by 2, then we are storing what? 22 inside of doubled. So let's go ahead and put 22 down here inside of doubled. Okay, very good. And then, of course, we're going to write out. Aha, our very first time writing out to the console. So let's go ahead and draw our console. And we write out doubled. That is a D. Equals 22. All right, very good. Now, where's our next area at? Well, we are finally at the end of a method, okay? So what is going to happen? This is very interesting. Well, we know that we can set our execution pointer back to the right spot because we have a return address. So we're going to what is called unwind the stack and set our execution pointer back to that return address. Well, what does unwinding the stack look like? It looks like this. Now, do we have a really good understanding of why local variables go out of scope once you have left a method? Look at doubled. Where can we see doubled now? We can't. Doubled has been erased from memory. We used it over here on the console. We wrote out the contents of it while we were inside that method. The show double method, you could say, its task was to simply take in a parameter, multiply it by 2 so that you have doubled the value, and echo it out to the console, the end. And that was the simple task that method performed. Very good. Now we are back up inside add num, aren't we? Think about it. Here we are inside of add num. Now all of our variables inside of here can be seen and can be used. Even though right now we've just done this line, so we're back here. There's nothing else to do on this line. So we'll go on down to the next one, which is to return back to return back to main. So the caller of add num. So we need to return back to whoever called add num. But I just wanted to point out that at this point right here, if I wanted to add more code that worked with our parameters num1 and num2, I still have access to them, don't I? Look at that. They're still in scope because we are back in the correct stack frame. Okay? But in this particular case, what are we doing? We are simply returning. But we're going to send the total value back. Well, total is currently set to 11. That's the total we're referring to. We're referring to this total. So we send it back. Well, who do we send it back to? Well, here is where we called add num. So you could basically look at this as becoming the result that's being sent back, that's being passed back. So we have return, its total, this total, is an 11. So you could look at this whole thing as like being an 11. So int total is going to equal 11. So I'm just going to go ahead and fill that in up here. Again, I'm generalizing what's taking place here on the stack. And we're done. We're at the very end, right? So since we're done at this point, we know where to return back to because once again we have the return address. So we know to set the execution pointer all the way back up here. Okay, back on the calling line. And what are we going to do to our stack? We're going to unwind the stack. So here we go. We're unwinding it. And it pretty much looks just like this inside the computer, right? A bunch of guys come out with an eraser. They erase everything. I'm just kidding. If anyone's taking me to heart, don't do that. So that stack frame is now gone. And these arrows are just pointing to nowhereness. So at this point, once again, if we were to talk about total, this total, num1, num2, the two parameters, they don't exist no more. They are truly gone because that stack frame has been erased. The only thing in scope at the moment is this stack frame. So now total gets 11. So 11 is now stored in this total. An entirely different total. And we all saw that because the other total existed in a different stack frame. And what are we going to do next? Next line of execution tells us that we need to print out on the console total equals 11 because that is the current contents of total as seen here. Okay? And then we are at the end of our program. Whew, there you go. Hopefully I didn't make it too confusing. Basically, we have three different methods. We have our main method, which defines our entry point into our application. We have defined two other methods, add num and show double. Both of these methods take in parameters. Add num takes in 2 parameters. Show double takes in 1. Add num has one return type. It has a return type of int. So it has something other than just void. Show double does not have a return type. So it's just simply set up as void. And then you saw me trace the entire thing, what's taken place over on the stack, and you saw how variables came into existence and how they were removed from existence as the stack was unwound. Logan, is there anything you want to add to this?
No, just to point out again what you were saying with the stack and local variables, and the reason that you can have different local variables and different methods with the same name is the reason that as you go into different methods, you're actually looking at different stack frames.
That's right. You're working.
You can create the same local variable over and over again, but if they're in different stack frames, they're still entirely different variables.
That's right, because when we were working inside of addNum, this is where our scope was. We were in this particular stack frame down here. So in this stack frame, this total that existed down here was completely different than the total up there. It's a whole different memory area, if you will. It's a different memory address. That's the bottom line. So Logan's absolutely right. Logan, did this seem confusing, or did it seem to flow pretty well?
No, it all worked in order, just showing that as you call methods, you basically create new stack frames, new local variables get put onto that stack frame, and then as you return from methods, then the stack unwinds by killing off that stack frame and erasing those local variables.
Precisely.
There's only one other thing I'd like to add, and that is in the addNum, return is actually specified as a statement because we have to tell it exactly what value we're returning. In the cases where we have methods that return void or return nothing, the keyword return isn't actually required. It's more or less just implied that if you hit the very end of a void method, you return. That's basically when you're inside a method, you're always returning, even if you don't specify the keyword. It's just that when you have to return a value, you have to specify what value you're returning.
Exactly. All right, let's go ahead and pull this back up. Whew, that was loads of fun. And here we are. Back to this screen. And at this point, if you guys don't mind, I'm just going to come up here real quick and hide my tools. Okay, so that was a very quick look at method calling. And I really hope that clears up any confusion that you might have in regards to when calling a method, what happens. You call upon the method, so we now hand execution off to that method. And then when we're done with that method, we return back to whoever called that method. So you may be in one method, call another method, and then in that method call another method. So when we return back, we return to the method that called it, and then when we return from that method, we return to the method that called it. You always return back to the caller, okay? So that was method calling. Now, terminology. A few different things that I want to take a look at. Let's see. How do I want to clean this up just a little bit? Let me think. Okay, a few different things that I want to show here. So first thing is going to be the method header. If I can write for 2 seconds. There we go. So what exactly is the method header? The method header basically consists of our return type, the name, and the formal parameter list. So if we were to come over here and look, so return type, name, and our formal parameter list, all the way to right there, this is going to be our method header. Okay, that brings us down to the next thing to understand, which is the method signature. The method signature consists of the method name and the parameter types, but not the parameter names, and also not the return types. So in this particular case, what would we have with addNum for our method signature? It would be add num, and what gets sent to addNum? An integer and an integer. Okay, that is our method signature. Finally, you may hear, and this one you won't hear as often, but I'm going to throw it out there anyways, argument signature. And the argument signature is basically what are we passing? Just the type. So in this particular case, the argument signature for addNum would be what? Int, comma, int. So depending on what we're looking for, so let me go ahead and just, since I'm right here, you can just write out that basically it's going to be int addNum And inside here, we had int num1 and int num2. And things like method headers, it becomes really important when we start getting into method overloading, and suddenly you have multiple methods with the exact same name, but the only thing that varies is going to be things like, well, the method signatures, where you're going to have different types of parameters in here. So we could actually have two different add nums. We could have an add num that takes in 2 ints. We could have an add num that takes in 2 floats. And depending on what data you send when calling the method, well, that's going to determine what particular method, even though the names are the same, which of those methods are going to actually operate. And we'll take a look at method overloading as we get to the end of this video. Logan, is there anything you wanted to add to this?
Just say that another way of saying that is that the method signature is the way the compiler breaks down the method so that it can determine what method needs to be called if you have methods overloaded.
You got it.
It's also, if you're using IntelliSense and you notice that as you start to type out a method, it actually hints towards what types of data need to be fed into the parameters.
Precisely.
So again, method signature in use, just alerting the compiler to exactly how that method's supposed to work and what it's supposed to accept.
Exactly. Okay, so that is a look at some basic terminology. Modifiers. All right, this is something that we have seen a lot of. So let's go ahead and start out by first taking a look at, you know what, actually, Logan, let's put this on another page, because I'm gonna start adding, well, several things to this. And we don't want to do this guy. Let's add another page. There we go. And we'll hide this guy temporarily. Let's start out with our access modifiers, because we can fly through these quickly. So let me jot them down, and then I'll just do a really quick refresher. We've got public, we've got private, we've got protected, we've got internal, and we've got protected internal. Which you, of course, could argue that, well, protected internal is not an access modifier. We're just using a combination of protected and internal. But it's just important to understand what's going on. So public, and again, very quick here. This all comes down to who is able to access or see this particular method. And, of course, this is governed one step higher with can you even see the class itself. But public basically means accessible to all methods in any assembly. Okay? Private means that it's accessible only in the defining type. Protected means that it's accessible only in the defining type or a derived type, which means, remember we talked about the inheritance thing, which is something we're going to be covering in the next section of videos in greater detail. So if we inherit, we have the ability to see that method, if we inherit it, of course, and then if we happen to be in another class altogether that's completely unrelated, in other words, it did not inherit from the base class where the method is defined, then, well, we simply cannot see it. It's protected. And then internal is accessible to all methods in the defining assembly, but external assemblies cannot see it. And then protected internal means accessible to all methods in defining assembly or in derived types in external assemblies. Logan, was there something you wanted to add?
Mm-mm.
Oh, okay. It looked like you were quickly trying to throw something in there. Again, we went into great detail on these in the last video with fields. It's the same thing, okay? So when you're working with data members, aka fields, and you go in there and you set it public, all you're doing is saying, okay, who can see this data member? As long as we can see the class, if it's public, then from anywhere else, we can see it. That's the key thing to understand, is it's who can see it. So that's the access modifiers. Like I said, the same discussion in the last video applies, so there's no reason for me to repeat it. So that allows me to quickly move on down to other modifiers. All right, Logan. And ladies and gentlemen, we just get a kick back here and kind of relax and have some fun, because there's two ways that we can present the following information. We could simply write them out and say that we're going to be talking about all of these in the videos to come, or we can give you some quick overviews with some of these. And I think the quick overviews is a good idea. I mean, we've got some things we're going to be talking about, like static. We have hinted at, okay, let me put it another way. We have told you what static is several times now, but we have a video that's going to be coming up later that's dedicated to it. But by the time we get to that video, you guys are honestly going to be experts with using static. But we've got static, we've got abstract, we've got sealed, we've got new. So we've got virtual and override that we're going to be throwing into the mix here. And these videos are going to, or excuse me, these particular modifiers have specific videos when working with these types of methods. We're going to just briefly talk about what they are. I'm going to throw out a quick example or two. And again, you know, if I'm writing out a whole bunch of code and you feel like fast forwarding, please help yourself. That way you don't have to feel like this is long and drawn out. You control that. But again, I feel it's kind of cool if we just give some sort of example or talk about at least what's going on. And then later on, when you get to these particular videos, you'll have already had a seed planted deep inside your head. And you'll go, oh yeah, I remember that. So let's start out with static. Static methods are great. Actually, they're going to become very important to us, well, real soon, as a matter of fact. But static methods, well, first of all, you got to understand, methods come in two different flavors. So you could come up here if you wanted to, and you could say methods. And the two flavors that they come in is static and instance. So you may be wondering, what are you talking about? Well, remember all the way back to the discussion of, okay, I'm going to create a class, and the class actually gets created on the heap, right? Let me come in here and undo that, and just try to draw it just a little bit nicer. There we go. So here we are with our actual class, and then from that class, we can instantiate objects. So here are instance classes. So these are actual objects. So we could say that this is our type object. And we could say that this is object A, and this is object B. Instance methods are methods that the only way to gain access to is through the object itself. So it's like the method is gone with the object. So if there was, let's say, an update method, to call the update behavior, you would need to do something along the lines of obja.update. This right here is an example of an instance method. Now, let's say that we had, this was derived from game item. Okay, so this is game item, since we love to pick on that so much. Back over in game item, we may have some other method. Let me think. Give me something quick, Logan.
Count objects.
So count objects. So count objects. Now check this out. In code, to refer to this, I couldn't say obja.countObject. That would actually be an error. I would have to do game item dot count objects.
So you would refer to the actual type object itself.
That's right.
Not an instance.
That's right. And there's a terminator at the end of this. Okay, so trust me there. So here, what are we referring to? We're referring to the instance. What are we referring to right here? We're referring to the actual class. Instance method type, static method type. Okay? Only one of those if you want to look at it that way. But very important thing, this is really, here's a great area to point this out. Think about like math. Okay, so we've got the math class. We've got all sorts of stuff inside the math class, right? Wouldn't it be horrible if we had to instantiate the math class into an object so that we could turn around and use the absolute behavior or the square root behavior?
Right, because it would make no sense to do that. You're going to look at something like absolute or the result of a sine wave, any of those things, that's always going to be the same. There's never a case where you'd want the mathematic absolute to be different.
That's right.
It's just the mathematic absolute.
Precisely. So you'd want it to be a static method. I mean, you just wouldn't want it to be. You wouldn't want to instantiate math.
You can actually contrast that with the random object.
Okay.
Because random, you might want that its sequence of random numbers to be specified custom. That's referred to as seeding it. You might want to set a custom seed. So in that case, you can't refer to an all-encompassing single type for random. You actually want to make your own instance of random before you start using it, because you want specific things to be set on your version of random.
Exactly. So that is static. And again, we're going to be spending a good deal of time with static, because we're going to be using it often a little bit later on. Okay, so moving on down, the next one. Oh, we've already talked about this one. New. Oh, real simple. This one is just a way to get the compiler to hush up for us, if you want to look at it that way. Remember, we can have a base class, right? And then we can derive from that base class. So this is our ever so popular game item. And then here is our ever so popular enemy. And we could have a method in here that's called take damage, or let's just call it damage. And then we could have a completely new method down here called damage 2. Not damage with the number 2, but also have a method called damage. Now by default, this guy down here will hide this up here. Okay? Now, the compiler is going to give you a warning letting you know that this is going on, and it's going to tell you that, you can use the new keyword to just basically tell the compiler that, hey, we know what we're doing. We know that we're hiding the one that we have, that we've basically derived from, and this is going to be the one that we're using. But like I said, it's not an error. Okay, that's very important to understand. So, anything you want to add to that, Logan?
Just another way to say that is, in general, you can redefine methods in descending classes.
That's right.
The compiler looks at that happening in two different ways, accidentally and on purpose. Without the new modifier, it's looking at that as accidentally happening and throws a warning. If you add the new modifier, it looks at that as on purpose and allows you to hide the method.
Exactly. Okay, so that's new. Now, and again, we gave an example of it in code in Visual Studio in the last video. So the next thing that we're going to talk about is abstract. All right, interesting concepts. Yes. An abstract method must have no implementation. That's the first thing. First of all, what is an implementation? The implementation is the body of the method. It's the code that you find inside the method itself. If I tell my daughter to go wash dishes, everything that she does to perform the task of washing the dishes is the implementation, if you will. Okay? So, an abstract method has no implementation. The second thing that you have to understand is that it must be defined in an abstract class. Now, we talked briefly about abstract classes back when we had the introduction to classes, our class basics video, okay? What is an abstract class? Well, an abstract class is a class that cannot be instantiated. You have to derive from an abstract class. The idea is to just make a class that is just as abstract as possible, that would contain everything that would be needed by classes that could derive from it, so that it serves as a very basic abstract building block. Okay? Well, we can do this with methods as well. And this is a very powerful technique, which we will get into a little bit later, or maybe even a lot later in time. But using abstract methods, basically you now have a method that you have to implement in a deriving class. So let me give you a very simple example in code. So let's say that I had something along the lines of public abstract class called actor. Figure we'll get into actors a whole lot in the very near future. So why not just go ahead and throw the term out there now, right? Not to mention anyone out there that may have played with Unreal Tournament. They have probably seen it a billion times. All right, inside here, what I want to do is go ahead and create. So here is my abstract method. Check this out. So public abstract void. Now let's give it take damage. Open, close, terminate. Okay? Very, very important. You have to have the terminator there at the end. It is required. Notice there is no implementation. There is no opening curly brace and a closing curly brace. That's it. Now check this out. Let's put this to use. Now I'm going to make another class that is going to derive from actor. And again, we're going to get into inheritance just a little bit later, though by the time we get into it, you'll have seen it several times, so that's going to be very handy. So here we are with another public class. This is going to be an enemy that is going to inherit from actor. Now, we must provide an implementation for take damage now. So check this out. Public. All right, so here's something new for you. Override. Void. Take damage. Open, close, but here's the kicker. Open curly brace, and this is where our code implementation would go. Closing, and finally closing. So what have we done? We've created an abstract class that contains an abstract method. Then we have derived from that class, or you could say we have extended the actor class into the enemy class, where we have provided our implementation for the take damage method.
And again, abstract is just a way of saying that you want to have functionality, but you don't want to specify what that functionality is yet. You want to put that off until a descending class.
That's right. And believe it or not, this is a lot more powerful than it may look. But this really does get into object-oriented design issues. And we will come back to this a little bit later on in time. But it is indeed a modifier available for methods. So like I said, I wanted to go ahead and introduce you to these as best I could at the moment. Now, this is going to move us on over to a couple of other ones that we've got videos that are going to be coming up real close on. Check this out. Now, so I'm not going to start coding these guys out like crazy here. Abstract is something that you may see a little bit later on, but this is something you're going to see very soon. Virtual. And override, which you just saw a second ago. Virtual is a big one, and you're going to see virtual all over the place. Basically, this modifier allows a derived class to supersede a base class methods implementation. Huh? What are you talking about? Well, quite simple. If I was to take a base class like, let's say, GameItem, and GameItem had update in it, and let's say that some classes may just use update, while other classes may derive from GameItem and need a different implementation of update. That means that back in GameItem, there was an implementation. So that's what makes it different than abstract. But now in a derived class, I can call upon the original functionality and add to it, or I could just completely replace it altogether.
Right, virtual and override gives you an incredible amount of flexibility when using methods as you inherit from different classes. It gives you the ability to change the functionality of a method in a derived class.
That's right. Now, right now you're probably thinking, okay, I'm confused because I'm still new to this whole object-oriented thing. Virtual, override? I mean, I can kind of see it in your little example that you just provided a second ago where you did override for take damage. Because we used abstract in here. Well, abstract is implicitly saying that, well, this is a virtual method. It needs to be overridden. We need to provide an implementation of our own, and that's what we've done. By using override, we've said, hey, here is our own implementation, okay? And again, We're going to spend a deal of time working with virtual and override, and we're going to start using it. Well, we're using it in precision, aren't we, Logan?
We should be. I'm just thinking really
We're
quick.
guessing, ladies and gentlemen. Okay, so we may not. But what's going to happen is it may be used in precision or not, but we're going to start using it real soon in all of the games throughout the rest of the XNA Xtreme class. I can guarantee you that. It's going to get to the point where you're going to wonder how you made it without it. Okay, again, as Logan said, it offers a great deal of flexibility because it does indeed allow you to change the behavior in a derived class of something that we inherited, a method's behavior. And again, we can call upon the originating data, or not data, but the
functionality,
the original functionality. So we can call upon that to take place and then add to it, or we can just completely replace it. But again, I'll make that nice and clear with whiteboard examples and everything when we get into working with virtual methods. Okay, very good. From there, we've got sealed. The names just keep getting cooler and cooler. Okay, let's pretend for a moment that you grasp the concept of virtual. Let's say that we had a situation. So here's going to be my very quick and dirty example, where we had a class that had a virtual take damage. I'll just call it damage, easier to write. So it had a virtual damage method. Now let's say that I inherited from this class a new class. So let's say that this one was actor and this one was enemy. So now I can use override and I can redefine the implementation for damage. Okay? But let's say that enemy is going to be inherited from, and we're going to have different types of enemies. So let's say here's an example of us creating a spider. So let's say that I want to override damage in enemy, meaning I want to change the implementation somehow. But I want to stop the ability for it to be overridden anymore. So what I could do is I could come in here and I could say, let's create a sealed override damage. Okay. Now, damage down here cannot be overridden again. It's now been sealed. So I can inherit, of course, as long as it's public, down there in Spider, I can make use of it. But I cannot override it again and change its implementation or add to its implementation, right?
What that would allow you to do is set forth a standard for the way that all enemies should handle damage.
Exactly.
In such a way that no derived enemy could change that. That way you would just have a standard. All enemies would handle damage in the same way, and it would be impossible to change that. So therefore impossible to break your standard.
Precisely. And again, this may seem like a very confusing concept at the moment, and if it does, that is okay. This video is being set up in a way that you can use this as a reference later on in time when you have a better, a more solid understanding of working with some of these, let's say, more sophisticated modifiers. You can always come back to this video and enjoy a good laugh going, oh yeah, that was actually pretty simple. But that is sealed. From there, let's take a look at one final one, and that is going to be extern. All right, what extern does, this is really outside the scope of this entire class. I can't think of any place we're actually going to use this, Logan. Of course, now that I've said that, it's going to definitely creep up on us. But what this is basically it is a method that was implemented externally, typically done in another language. Like over in C++, may have written a library out that implemented methods that you're then going to use inside your code. And through proper referencing and all, you can basically set it up so that we are aware of this method, and it is basically defined elsewhere. It's implemented elsewhere. So that's what extern is doing. It's letting the compiler know that this was implemented externally. Okay? And like I said, that it's really outside the scope of the 101 class, but that is what extern is. Okay, so that takes care of all of our modifiers. So let's go ahead and just kind of push back up here. All right, we're starting to add quite a few notes, Logan. So yeah, watch how scary this gets. Oh yeah, sweet. So let's go ahead and jump all the way back down here. So modifiers are now out of the way. Parameter passing by value and by reference. Oh man, so important. And technically, we've kind of taught it to you already. Back up here on the method calling video, on that video right there, we walked through the stack, right? And through doing that, you saw us passing by value. We were passing copies of data. But it's very important to understand that we do indeed have parameter modifiers. Remember, let me go ahead and grab an arrow real quick. Back down here, parameter syntax. Remember, with our parameters, not only can we specify a type and an identifier, but we have the option of specifying a parameter. This is where we can go in and we can do things like say that we want to pass by reference instead of value, or use out. So some very interesting things. But let's go ahead and bring up a whiteboard and show you what exactly I am talking about. So first things first, a new whiteboard, and we'll hide all this. So parameter passing. By value and by reference. Please pay very close attention. This is very important that you grasp what is going on here. Let us say that external to a method. So let me draw a method for you. You know how I love to draw those methods? Boxes. So here's a method. A little bit crooked, but we get the idea. And let's say that I call upon this method. And when I call upon it, I use, like remember how we had addNum, and addNum took in two parameters, an int num1, int num2. And then I had, I basically set up some numbers. I had int a and int b outside of the method, and then I sent a and b to it. Well, let's pretend we've got the same type situation right here. So let's say that this is like a, right? And we'll put a value in it. We'll put 5. And then down here we've got a parameter that's going to be taken into the method. What happens is when I call upon this method, I send a copy of the data. Which means if I was to modify the data somehow, so let's say times 3, and that, the result gets put back over into A. So what's the result going to be? It's going to be 15. When I return back to my caller, has the value been modified? So in other words, let's just write this out real quick. So if I had something along the lines of int A equals 5, right? And then down here I've got, let's just say that this is a void. Simplify this real quick. I'm just making this up real quick. So we'll call this void multiply. And it takes in int, heck, we'll call it A. That'll work. And inside here, all we're doing is we're saying that A equals, I'll write the whole thing out. A equals A times 3, terminator. And now we call multiply. And we pass it A. Now we saw how the stack works. We saw that the A out here is a different A than this A. This A is going to belong to the stack frame when dealing with this particular method. Now this right here, the default way of passing a parameter is by value. And by value means a copy of the data is then passed into that stack frame, into the local variable or the parameter for that method.
Well, right, like you just said, the way the parameter is handled inside that method or inside that stack frame is as a local variable, a different local variable than anything outside of that stack frame. So if you define int a as a parameter for multiply, then you have a different local int a than you do for the int a that was defined outside of multiply, where the int a equals 5. Those two variables are two entirely different variables. Any change to one will not be reflected in the other.
That's right. So if we were to write a equals and then whatever is in a, we would actually see 5. Even though right here, this a contains a 15, what happens when we are done with this method? Well, the stack frame, the stack unwinds, we return back up here and continue with execution. All of this stuff has been removed from the stack, and we never change the a back here. So when we continue on the next line, write out what's an a. Well, what is an a? It's a 5, because we passed by value. Okay? Now, passing by reference, that's a little different. And we're going to look at a couple examples. I'm just going to draw out a quick graphic. Same scenario. Let's say we had the value 5, right? And we passed by reference to the method. That basically means we're dealing with the same data, which if I was at this point to come in here and do something like times 3 and store the results back in here, it's the same thing as restoring the results back in here. So this becomes a 15, but that's a 15 as well. It's the same thing, okay? Because we've passed by. We're referencing the same area in memory. We're referencing the same data. So any modifications we make inside the method, well, it's modifying the same place because it's a reference. That's the key thing to understand here. This is very closely related to the concept of reference types, where if we have, remember we have object A, and then we have object B equals A. Any changes to B, B.x equals 3, if we print it out, what would be, say, print out A.x? Well, what's A.x going to print out? It's going to print out a 3.
Because A and B are actually pointing to the same instance.
They're pointing to the same thing. The same concept is taking place here, but it is different. You've got to be careful because this is where one can get confused really quick. Let me erase this and show you what I'm talking about. You have heard us discuss value types and reference types, but this is passing our parameters by value and by reference, which means let's give the example one more time, but let's do it this time around with an actual object. Because you've been seeing how we've been passing just very simple integers, floats, things like that over to methods. But we can pass objects as well. We can pass instantiated classes. So let's do just that. Let us say that we have instantiated game item and we now have a player. And then we have a method that we have to call. Let's say we have like, we have like a game object, right? It has some sort of update method inside of it, and it's expecting you to pass an object to it, or a damage, because we're going to use damage here shortly. So I like that idea. So let's say that we have this damage method. And damage method takes into it, well, what does it take into it? Remember, first the type, so it would take a game item. And then you can call it whatever you want it to. We'll just call it X at the moment. So here's X. So we pass player into our method, okay? So player. Well, how do reference types work? A reference type on the stack is really a pointer to the heap pointing to your actual object. So here's our heap over here. Heap. And on the heap, we have our object. So there's the real player. And let's just say that the player has a position X. Now, let's go with health. I've done position X too many times. All right, so he's got 75 health points. All right, so we've passed player down there to damage. And now inside here, if we come in and say dot health, if I can remember how to spell health, all of a sudden I forgot, equals 100. For whatever, I'm just making something up, but just bear with me. What is happening? Well, what do we actually pass down here into player? Well, what is in player to begin with? It is a reference to this guy. So what does that mean we pass down into damage? A reference to this guy. Okay? That means that if we were to say, set health to 100, well, what's health going to be? Well, it's going to be 100. Now let's say we're done with the method, and we come back up here, and we continue with execution, right? And the next thing we do is we say print out what is in the player's health. So player's health. Well, it's going to print out this 100 right there. Well, that's very easy to mistake as a, ooh, well, we passed by reference. No, you did not pass by reference. You passed a reference type, which means we were still referencing that same object. Remember, we weren't actually manipulating the data in here, were we? No, we were manipulating one of its data members. That's what you need to understand here. The key thing is, well, what happens if we did manipulate the information inside here? Well, what kind of manipulation would we be doing? Let's think about it. Well, probably pointing to a new object. So if we were truly changing what was stored inside the player variable, that means we would suddenly reference a new object. And let's say that we had set the health down to 10. Okay, well, in this new object, health got set to 10. But when we return back, if we then printed out, show me the player's health, it would still be pointing to this guy. Because remember, things that take place when passed by value inside a method, it's done locally in that method. We don't affect outside of it because we passed by value. So even though we are working with a reference type, we're still passing by value. But we do have the ability to pass by reference when dealing with a reference type. And we'll see that in a few minutes in an example. It's the best way to show it. So far, so good, Logan?
Right. The key to remember there is that with a reference type, the only thing that you can assign a reference type to is another reference. You can only change the reference. You can't actually change anything else because that's really all it is. All the reference does
it's just a reference.
Is point to an instance. So the only thing that you can assign it to is another instance or the same, not that that would change anything.
Exactly. So what happens if we do run into a situation such as this, where we want to make sure that inside the method, whatever we're doing with a particular parameter is affecting a variable outside the method? Well, there's two ways we can go about doing this. We've got two parameter modifiers that we can use. We can use ref and we can use out. And they look very similar in the way they act. It's a subtle difference, but an important one. Basically, when working with ref, I'll say this, then I'm going to give some demonstrations, and I'll say it again. When working with ref, what has to happen is that your variable needs to be assigned before you call the method. So, in that particular case, this variable would have to be assigned if we use the modifier ref. It would have to be assigned before we could pass it down here to this method, okay? Without, so that is our other keyword. When using out, I don't care if you assign it beforehand or not. It's irrelevant. It has to be assigned inside. So when using out, it has to be assigned inside the method. Okay? So if we had initialized it outside the method, it's going to be irrelevant, okay? Because it's obviously going to be replaced inside of the method. And this is really handy if you need to create a variable. Let's say that you were making an application that had a variable and you didn't want to initialize the variable because you don't know what value that variable is going to have until after a method is called. Well, out is a perfect place to use that particular scenario because you could just say int x. Now let's call this method and pass x to it, but we're going to use the out modifier. Now, inside that method, it has to initialize. So the compiler knows it's cool to do this because it has to initialize x inside. And then, of course, well, we're outing that information. So x externally becomes initialized, if you will, thanks to the method. Now, you might be thinking, okay, whoa, my head now hurts. we need some examples. Examples will make all of this clear. Let's start out with the real simple one to see, and that is the reference itself. So, look, I'm going to go ahead and pull up yet another screen. Boy, we're turning this one into an awesome video. This one's getting nice and lengthy. All right, so we're going to take a look at ref. As a matter of fact, Logan, in this particular example, after I write this out, I'm probably going to have you code it as well. So let's say that we have our static void main. Yeah. Okay, just because I don't want to write all that good stuff out. And then inside here, int, let's stick with A. A equals 5. Okay, now what I want you to do in a second ago is to write out before call, so everybody's nice and clear on what's happening. Before call, A equals, and then just concatenate A to it. Then let's call double me, and let's pass A. We'll just start out real simple. And then after we get back from the method call, let's write out after call A equals, and let's show them that A hasn't changed because we passed by value. So down here, of course, let's do a static void double me, and double me is going to take in an int num, and inside here the only thing I want us to have is num times equals 2. And come on, you guys remember that's the same as saying num equals num times 2. Alright, so what's going to happen when we run this? Basically, we'll have the variable A. It's going to be initialized to a value 5, so we're going to print out to the console. So here's my console right here. It's going to say before call A, I'm not going to write all that out. A equals 5. Then we're going to call double me. We're going to pass it A. So A comes in down here. And what do we do with it? Well, it's not A itself. It is a copy of what is in A, which is 5. So we're then going to take that 5, multiply it by 2. All right, so that gives us what? 10. Okay, very good. And then we simply come back out. Well, that stack frame is eliminated. It's erased. And then A is still a 5. So we come back out and we say after the call, A equals 5. Very simple. So Logan, let's go ahead and write this real quick, just so that they've seen us do something inside of Visual Studio.
All right. To show this example, I'll start a new console application. And let's see. Do you want to code in
just
main?
Code in,
okay.
Yeah,
or
just code it
the
straight
method?
into main. So
okay.
Yeah.
Well, first we want that integer A. We want to initialize it to 5.
Okay, now let's do a console.writeLine.
So we'll grab our console and we'll write a line that says
before call, colon, space, A equals, and then, yeah, beautiful. All right, and now let's call double me, and we'll pass it A. And then let's go ahead and do, yep.
I'm going to get lazy and just copy this line so that I can go in and change before to after. So we've got after call A equals whatever was in A.
All right, now let's go ahead and create our method.
So I'm going to jump down outside of this main method where we can create our own static void double me, where we will take in the integer num.
All right. And the implementation is simple, num times equal 2. All right. So once again, what should be printed out? Before call, A equals 5. After call, A equals 5. Let's go ahead and let's put a read line in there.
Yeah, let me throw in a read line so that we can see what was written out. And read line. Very good. And now we can run.
Okay. And before call, A equals 5, and after the call, A is still equal to 5 because, as I demonstrated earlier when we took a look at method calling, the stack frame gets erased when we return back to the calling stack, which means num went away. Num had no association whatsoever, no reference back to A. Now,
so basically we made a variable num, we put a value into num, erased num, And went back to running outside of it.
Exactly. So, what if we actually wanted there to be this reference? Well, it's real simple. We use the ref modifier. So we can come in here and we can say ref int a. Well, excuse me. I'm gonna keep a num. I don't want to confuse anybody. It could be a. Call it whatever we want. There we go. Now, the key is this. That means back up here, we also have to specify ref. And then send it our value. Now, by doing this, this puts a reference back here to this variable. So this value right here, when we change any value in double me, so in other words, we're affecting num in any way, we're affecting a. We are directly changing the value 5. So what's going to happen here is we're going to get, before call, a equals 5. Well, picture it as like we are truly working with a inside here. So num times equals 2, so 5 times 2 is 10. Well, a is now going to be 10. So when we get back outside, you'll notice there's no magic here. We're not returning anything. So there is no tie to the outside world other than the reference back to our calling argument. Okay? That is where we get this association, this reference. So by changing num in here, we are changing a back out here. So we should see a equals 5, and then after the call and when execution continues, a is going to now be equal to 10. It's going to be equal to the result we came up inside the method double me. So Logan, let's go ahead and add that in.
All right, let's jump back to Visual Studio, and let's first change the double me method to take in a reference, a ref int num. Then back where
go and try to compile it. Show them that it's a problem. Aha, we've got trouble. We need to go ahead and says argument 1 must be passed with the ref keyword. Let's go ahead and add ref up there, then right before a. Now let's compile. All looks good, and let's go ahead and execute. Look at that. Before call, a equals 5. After call, a equals 10. Exactly like demonstrated over on the whiteboard. Very, very important concept to grasp. When you want to pass by reference, in other words, you want the method to modify a variable's content that is external to the method, pass by reference. All right, this next example, something perhaps a little bit more practical. Well, hang on. Logan, do you want to do this example first, the bigger one, because it's dealing with ref when dealing... No, we'll come back to it. Let's keep it real short and simple. Guys, this has turned into a huge lesson on the fly, as we sometimes have a tendency of doing that. And I'm deciding to shuffle around one of the examples, which is a much bigger one. I'm going to put it on hold for just a couple of minutes. So we've taken a look at ref. So let's add yet another page. All right? Now we're going to look at out. And with out... Remember, I told you the big difference here. Again, we're in a situation, excuse me, where inside a method, I can affect the contents of a variable that's external. The key thing is that that variable has to be initialized inside the method itself. And we've got a very good example here where we're actually going to be using the XNA framework, and we're going to be using a vector. So, same type situation. So real quick, a static void main stuff. All right, we're going to create a vector 2, something we're going to be working with a lot in our games. And we're just going to call this variable a vector. And we're going to say that this guy is equal to a new vector that is going to have vector 2, 15.5 float, and 12.2 float. Look good, Logan?
Sure, looks good.
Those numbers sound great. Okay, then let's say, all right, first of all, what's a vector? Well, 2 numbers in this particular case. Okay, so it's going to contain an x and a y. It's kind of like a point, but and when I say point, think back to when we were doing canon 1, canon 2, canon 3. We were dealing with points all the time. But what were points? They were integer values represented with an internal data member x and y. Well, with a vector 2, we're now working with an x and a y that are of type floats. Okay? So let's say that I wanted to extract those floats out, and I wanted to put them in a float x and a float y. So let's pretend that I have a method set up called get floats. Its job is to get the floats out of a vector. And what do we pass to it? Well, we're going to pass in a vector 2. So in this particular case, we're going to be passing vector. Remember, it's going to be our actual variable name. And then x and y. Notice I'm leaving space because that's where we're going to put out in just a second. Now, let's go ahead and terminate this. After we do this, Logan, what I want to do is go ahead and write out what x is and write out what y is, just to prove that it worked. And that will basically wrap up the main method. So now down here, we're going to have a static void get floats, which is going to take in a vector 2. Remember, type first, so vector 2, and we can call it a vector down here. Call it whatever you want. Now, let's go ahead and start using this out modifier. So, out float x, and give myself just a little bit more room, and out float y. Okay? By using out, we have to do the exact same thing we did with ref. It has to be used up here on the calling method. So we have to use out in both locations. Okay? Now watch this. This is where things get really simple. So inside here, all I have to do is say x equals vector.x. Terminate. Y equals vector.y. And those are actually capital, but you get the idea. And then finally, the end. All right, so what's going on here? First of all, let's completely back up. This is for my beginners that are looking at this going, oh, vector 2. Vector 2 is just a struct. It is an actual value type. Inside of it, we contain a float x and a float y. What is a float? A float is a number that has a decimal point. End of story, okay? And we are creating, right off the bat, we are creating a vector 2, and we're storing, it's called vector. That's the name we're giving it. It could have been called x if we wanted to. Well, that would have been really confusing.
Or position.
Or position, yeah, anything like that. But we're creating it, and we have to use the new keyword. And when we say new vector 2, I'm initializing it. So I'm putting 15.5 float and 12.2 float inside of it. Okay, so now it's been initialized. But now I need to gain access. I need to get to it. Check this out. I have declared two variables. I have not initialized them. That's the key thing to understand here. I have not initialized them. Now remember what I said. When using the out parameter, the out modifier, the initialization must take place inside the method. We're initializing it, aren't we? We're assigning, utilizing the equals operator. So when we call get floats, the compiler knows that as long as we're assigning down inside of get floats that everything's cool, because there's no reason to complain that x and y externally have yet to be initialized, because it knows there's not going to be a problem, because initialization is going to take place right here. And because we're using the out modifier, that is saying that the information that goes into this and this is going to be in this and this. It's like reference. It's just like reference. Okay, that's the thing to understand here. Except for the assignment, the initialization has to take place inside the method.
Or it's like you're taking reference and sending the information in the other direction.
Yeah.
Where passing by reference is passing an actual pointer to a variable into a method. So you're dealing with the real variable inside that method. Out works the other way. You still handed a method a place where you want to store, or excuse me, you still handed a variable a place where you want to store data, but you allow that method to take some information and put it out into that variable.
Exactly. They've seen this before. They've used parse, haven't they?
Try parse with.
We actually covered parse and try parse. But remember, you used out in that as well, saying that if we do indeed have a true numeric value in this string, then out it to the variable that we set up to hold that particular numeric value. So you guys have seen it in previous videos, but here you are getting a true definition of what out does. So Logan, let's go ahead and give them this quick example. This is going to be neat because they're going to get to see where vector2 comes from.
So what I'm going to do is discard this project and just start a new one.
Okay.
We'll start a new console application. And right off the bat, let me see what happens when I try to define that first line. If I try to write out the vector2, vector equals whatever line.
Okay.
So if I make vector2 vector equals new vector2.
It's already very unhappy. It doesn't even have an IntelliSense.
And if I pass it 15.5f and 12.2f and finish it off and try to build, we get a problem. Vector2 could not be found. Now, this might seem odd if you've been playing around within XNA, within a Windows game.
Sure.
Because of all the references that are already set up, you're going to have Vector2 available. But there's the key. What references do we have? As a matter of fact, let's do it step by step. Let's try to reverse engineer this for a second. What if you had been paying attention in XNA in a Windows game and saw that we were using Microsoft framework.xna?
Okay.
Let's add that in and see if that would work. So using Microsoft.xna.framework. And already this also looks unhappy because you see it didn't show XNA or framework. If we try to build, now we get a problem with the namespace that we're trying to use. We can't even tell it to use this. The problem goes back to the references. And as we had shown in some of the examples demonstrating internal with use with assemblies, we need to add a reference to this solution, to this project more specifically. We need to go up to references. We need to add a reference. So we'll right-click on it, go to Add Reference. And now from here we can look through all the references we have within .NET. And if we scroll down, we can scroll down to Microsoft.xna. And there's Microsoft.xna.framework. If we add this reference, we can now use this namespace, so I'll rebuild. Now this namespace is okay, and Vector2 becomes available to us.
Very cool. A good thing that you pointed that out. Now, do keep in mind, you obviously have to have the XNA framework and all installed. Otherwise, that's not going to happen. So now we've got this line set up. Very good. So let's go ahead and create a float X and a float Y.
All right, float X and float Y, neither of them initialized.
Okay, now let's go ahead and make a call to get floats, but let's not use out to begin with. Let's just pass it the vector X and Y.
I'll pass it vector, pass it X, and we'll pass it Y.
Okay, now let's go ahead and do some write lines, some console.readlines.
So console write line, this one is going to be for X, so I'll write up something like X equals, I'll add X to it. As a matter of fact, let me make all of that lowercase as well, just so that makes more sense. And then I'll quickly copy that line, paste it so that I can say Y equals to whatever value is within Y.
And let's just do a quick read line.
And finally a read line so that we have a chance to read what was written out.
Okay, very good. Now let's go ahead and define our method getFloats.
Okay, this will be a static void getFloats.
And let's just have it take in a vector2 and a float and a float.
So we'll take in a vector2. We'll name it vector here as well. We'll take in a... Wait, it's saying, did you just say out or not out?
No, let's not do out. Let's just take in a float X and a float Y.
All right, float X and float Y.
And in here, let's just simply say X equals vector.X and Y equals vector.Y.
All right, X equals vector.X, Y equals vector.Y.
Now, I can tell you already that the compiler is going to be very, very unhappy for the simple fact that we are calling upon a method and trying to pass it 2 arguments that have never been initialized. the compiler is going to be very unhappy about that. Let's go and try to build. Oh, gee, what do you know? Use of unassigned local variable x and y. Unassigned being the key word, and look what's underlined right here and right here. So this is a scenario where we'd want to use out. The initialization of x and y is going to take place inside this method. So the compiler is not going to be upset about these guys not having been initialized before this call, as long as we're using the out modifier.
Okay, so we can begin by modifying our getFloats method to specify both of these parameters as out. So we'll have outFloatX and outFloatY.
Okay.
Now we can go back to where we are calling getFloats and specify that we want outX and outY.
Remember, that's required, just like with ref. You have to have it on the calling method. Okay, let's build. Beautiful. All right, you got the read line in place, so x and y should contain, x should be 15.5, and we should have 12.2 for y. Let's go ahead and run it. Oh, look at that. Isn't that cute? Just like we said. Okay, again, this is important if you end up in a situation where you have got a variable and you're about to make a method call, and this variable is going to be initialized by the method. That is where you'd use out.
Another cool thing, another way to look at it is, let's say, of course, if you were just using a method to set a value and you were only setting one value, you could easily do that by getting the return value. If we were only trying to, if this method was getX instead of getFloat.
Listen very carefully to what he's saying here, because this is tricky. This is good.
As a matter of fact, if you don't mind, let me even write that out just to show what I'm saying.
Mm-hmm.
Let's say a more simplistic version of this could be a static void getX, where it would take in, and I'm going to steal some code. I'm going to actually steal these parameters. So this method getX is going to take in a vector and, well, nothing else. I'm just going to take in a vector, and I'm going to change this a little bit just to show the difference between returning and out.
Sure.
So let's say we had a static, not an int. Let me get this straight. Let's do a static float getX, where we take in a vector, or excuse me, a vector2, and we return vector dot x. So we can build, everything's fine. If I take getFloats, let's see, let me just jump down below to show how this would be used. If we said x equals getX, we take in vector, and then just for temporary purposes, I'll comment out getFloats, and I'll comment out y, because if I try to build now, y is unassigned. So I'll comment out y just to get it out of the picture. Now everything builds except for the warning, which I'm not worried about. I can run and show that x is 15.5, so x was indeed read out from this vector2 called vector.
But it was passed back as the return type, that return data.
So we made a method called getX, and its job was to get the x component out of the passed vector2 and store it in x.
And we used the return type, and in our method itself, the method header, we actually said the return type is going to be an int.
Now what if you were at this point in code and you decided that instead of getting the individual components, it would be convenient to have a method that could get both components at the same time?
Mm-hmm.
Well, we've already used up our return. There's nothing else we can pass through the return of this method. Now, if we start using out, it's as though we have the ability to return as much information as we want.
Right.
If we take out getX and put in our getFloats, now we have something that acts in a method similar to getX. I'll bring this last comment out. So we have a method that acts similar, where we are getting x, as seen here, but we are also getting y. So we're actually getting two values back out of a method by using out.
Exactly. So very powerful using it that way. What Logan's saying is simply, well, if you need a method to return more than one value back, use out. Okay? Very good. Okay, so that is... I think that's everything that we wanted to demonstrate in regards to ref and out. Work for you?
Oh, yeah, it works for me.
Okay, so let's see. Next thing. Oh, yeah, big example. Let's go ahead and do the big example before we...
And wrap up ref.
And then we can wrap up ref. We're going to move back to ref for just a second. And what we want to do is demonstrate a situation of working with passing a reference type by value and by reference. This gets really interesting here. So best way to do this, instead of me trying to whiteboard this out, I'm going to let Logan code it, and then we're going to walk you through it, because we're going to have some new concepts in place that we haven't really covered yet, but I really want you guys to see this. So Logan, go ahead and start coding.
All right. And I'm going to begin by discarding this project and starting a new one. and we'll have, again, a console application. And I'm going to write the classes out to this one first. This example is a little bit heavier, so just have fun, enjoy watching the classes, and then we'll demonstrate them after they're in place.
Fast forward, because you can do it.
All right, I want to begin with the game item. So I'll have a class game item, and game item is going to contain two public fields. We're going to have a public string for name, and we're going to have a public, if I can type, of a public int for health. And I'm going to change these to uppercase, just since they're going to be referenced outside of this class.
So he's created a couple of data members, both public.
Now I want to create a constructor for this class.
All right. Now, as Logan is typing this out, we have not yet got to the video covering constructors, but a constructor always exists for a class. It is a method, a special method, that has the exact same name as the class. Now, you may have created several classes at this point where you did not create a constructor, and you may be thinking to yourself, well, that's not true. Well, if you do not create a constructor yourself, the compiler creates one for you. The constructor is a method that allows you to, well, do what Logan's doing right here. Initialize data members and do any other sort of setup when you instantiate a class. So in this particular case, when we instantiate the game item by, let's say, creating a player, you can create it and send it. So when saying game item player equals new game item, and then you do the open parentheses, you can actually, in this case, send an item name. So you can say, like, Bob. And it'll create Bob, and not only will it create Bob, because you can see where we're setting the data member name to whatever comes in, so it would be Bob, and we're setting the health to 100, and we're also letting everybody know that this class was just instantiated by saying Bob was born. So the constructor, again, is a special method that simply gets called when instantiating a class. Again, we'll cover that in more detail later, but that's important to see right now because this is going to be really handy in watching what happens when we pass a reference type by value and by reference. Okay.
Right, and the reason I had set this up through a constructor is it allows me to have some things automatically happen when I call this from main. That way I can have fewer lines of code in main, and it makes it more clear to see what's happening, what's actually going on.
Precisely.
All right, that takes care of game item. Now I want to make another class called game, just to set up a theoretical scenario when we had some game manager class that's going to allow us to damage game items. And outside of this class game, I want to have one method. We'll have a public void damage method, where we take in what game item we want to damage. Do you want to do? We discussed the. You
can do it either way you want.
I'm going to start it with by reference, just
okay.
Since that's what we've been demonstrating.
That sounds good to me.
So let's pass in a game item by reference, and we'll refer to it locally as game item with lowercase g or with camel case. And we also want to pass in the amount of damage we want to do to that game item, and we'll just call this damage. So we have method damage takes in a game item and how much damage to do to that game item. Now inside of this, I want to actually apply the damage. So we'll take the passed in game item, we'll set its health, and we'll actually subtract or decrement the health by whatever was in damage. So we take away damage amount of health. Then after we do that, let's do a check and see if this much damage has killed the game item or not, or if the health has reached or passed 0. So let's do a check. We'll do a check on GameItem.health, and if GameItem.health is less than or equal to 0, then we have killed this game item. Otherwise, we have only damaged it. So if we have, let me do the simple one first. Let's do the case for just taking damage. Let's write out to the console and indicate that damage has been taken.
For taking the damage, and you're going to want to do the else.
All right, okay, I jumped onto the else and you had jumped up to if. I thought you were redirecting me or that I had gone.
Oh, no. It's all good.
I got you now. I'm with you. Let's do a console write line where we write out the game item's name this time. So let me get game item again. This time address name, and add on to it that as though this game item was saying something like ouch. Just to indicate that game item was damaged.
You better put that exclamation point in there.
There you go.
There we go. That hurt.
So if we have just damaged and not killed the game item responds by yelling ouch.
Okay.
Now if we have killed the game item, let's reflect that that game item has died. So let's do another console write line. I'll write out, I'm going to steal some stuff. Matter of fact, I'm going to steal all of this because I can just change the string. So we'll write out the name. We'll change out the message to has died, or even just died.
Okay.
So we have name died. After that, let's say that after an item or a game item dies, let's replace it with a new one.
So a new one is spawned.
And let's not just create it, but let's actually store it in game item. So we'll say game item equals new game item, and since game item has a constructor that requires parameters, we have to pass it some name. The name for the new game item is going to be new guy. And we've got that. Alright, that looks good for damage.
So there's our game class, there's our game item class. So now let's go ahead and use these two classes.
Alright, first let me create an instance of game, just so that I have one to use for damage. So we'll say game is equal to new, well, not namespace, we want new game.
Okay.
Then we want a game item. I'm going to call this game item player. So I have game item player is equal to a new game item, and again, because game item requires parameters, we have to specify a name. Let's call this game item Bob with a capital B.
Okay.
Now, let's take this game item and damage it. So we'll use the game object itself. We'll tell it to damage. We want to tell it to damage a game item. This has to be passed by reference, so we'll say ref game, actually reference player. And we want to damage it with only maybe take 50 points of damage.
Okay.
Then let's turn around and write out what the current health for player is. So we'll jump down a line, and then we'll write out to the console. We'll write out the line player dot name, so we know which player or which game item we're looking at. Well, let's add on to that. Whoops, let's not jump down a line. Let's add on a string.
Apostrophe S.
Let's do apostrophe S, health is, and then concatenate again what the actual health is. So player dot health. And then finally, let's do a read line so we have a chance to read what was written. So console dot read line, and now we should be good to go.
All right, let's think about this now. So what happens when this game or when this application is run? The first thing we do is we instantiate game into game. So basically, we have a game object. Next thing we do is we instantiate game item into player. So we now have a player. So we have two objects, a game object and a player object. Well, here's the way. With game, nothing special happens when we create an instance of game because there is not a constructor set up to do all sorts of interesting stuff. With game item, there is a constructor. When creating new, now you actually get to see how it works. We're making a call, if you will, to the method game item, and we're passing it string information inside the double quotes. So here is class game item, and there is a constructor inside it, a method with the exact same name, and it takes in a string. So when we create this player, we have the ability to name it right there on the spot. So we're setting the data member internal. So here's the data member name, internal to the class item. So it's the player's actual name is being set to what we send into the constructor. So player's name is going to be Bob, and his health is automatically initialized to a value of 100. And Logan's going to show you this is just going to take care of itself now, which is really cool. He's going to have it automatically just echo out Bob was born, because that's when any time we create somebody, we pass in that name, it's going to let us know that they were truly created, which is good. Then he's going to turn around and he's going to call upon the game's damage behavior, which is expecting for us to send in a player and how much damage we want it to do. Here's the kicker of this example. We're passing the player, which is a reference type. We're passing it by reference. Why are we doing that? Well, let's come down here. This is very important to see. When calling upon damage, which takes in a game item type and an amount of damage, By passing it by reference, what that does is it makes sure everything stays synced properly if we end up in a scenario where the health is less than or equal to 0. If the health is less than or equal to 0, what do? We write out to the console that Bob died, but we create a new game item. This is very, very important because this new game item is stored inside the variable name game item, which is of type game item, okay? But we're referencing where we send this information in. And this is what's so important right here. This means that if that new player gets created, that new player is assigned right here. So if we turn right around with just 50 points of damage, nothing is going to happen other than we're going to see ouch, and then we're going to see what Bob's health is. But if Logan sent in like 200 points of damage, what's going to happen? Well, we'll drop below 0. We'll end up with a new player. But since it's a reference, we're referencing that new player out here as well. So we're in sync properly. In other words, we still don't have a seriously wounded player back here with 200 points of damage being removed. It's best to go ahead and see this in operation first, and we'll walk through it again. So let's just keep in mind right now we're creating Bob. When we create Bob, the constructor is going to holler out Bob was born to the console. Then after that, we're going to call upon damage and send 50 points and Bob to be damaged. So we call upon the game. We send Bob in here. Bob's going to take 100 points. He loses 50. Actually, Logan, instead of 50, make it 75, just so that 50 minus 100 minus 50 is still going to be 50. So by doing 75, now we get down here. 100 minus 75 is going to leave his health, Bob's health, at 25. 25 is still greater than 0. So what's going to happen? Bob, ouch. Then we return back up. When we return back from the game, then we're going to simply write out Bob's health is, and it should show out 25. Let's go ahead and build. Run. And run. That's good. So Bob was born. Ouch. Bob's health is 25. This is exactly the functionality we were looking for. Now let's go ahead and close that. Now watch what happens if we take ref. Well, no, actually, yeah, no, that's good. Put 175.
All right, so if we up the damage to 175.
Now, real quick, 175, and we send Bob down here to get damaged. What happens? Well, we take 175 away from 100, which puts us negative now, so that is definitely less than 0. So we fall into this section of our if block. We're going to write out Bob died, but then we reassign our game item to point at a new instance of game item, and we send new to it. So not only are we going to see Bob has died, but we're going to see new guy was born, and then since this was done by reference, when we return back up here, we're going to get to see new guy's health is 100 because the new guy, when he was born, new guy's name was assigned, his health is initialized to 100. And then we printed out that he was born. So when we get back up here, his health is going to be suddenly at 100. And we'll let the garbage collector come in behind us and clean up the old object, Bob, that's still sitting out on the heap. We're done with it. Now, we haven't done anything with him ourselves except for pointed our reference to a new object. And the garbage collector will clean up the old object. Let's go ahead and run this. And there you go. You can now see everything. So coming in here, Bob was born. Poor Bob died. New guy was born, and then we return back out, and we still are pointing. Player is pointing at the new guy's health is 100. And that's what we wanted to see here. That was the key thing, that we went from player being Bob to player suddenly being new guy. So everything stayed synced up properly. Now watch what happens if we take ref out. This means even though player is a reference type, we are passing by value. So since we're passing by value, when we get down here and we get into this situation right here, this game item is not referencing the same game item that player is back there. So we're going to create a new instance of game item. And this game item right here, this parameter, will point to it. But the player back here does not point to this new guy. He will continue pointing to Bob.
Right, he's unaffected by this new change.
Now, Bob's going to have a serious amount of health. He's going to have negative 75. He should be dead. What's going to happen is our new guy gets born, but then forgot about. Once we exit out of this behavior, out of this method call, we have lost our association with game item altogether. The garbage collector is going to come by and sweep him up when it gets around to it. But we will still have our reference to Bob back here. At this point, things are kind of out of sync with the functionality we're trying to get from this, because obviously we would want a new player to be born, not for us to have this negative 75 health. Logan, let's go ahead and run it and demonstrate. All right, check this out. Very important to see here. Bob was born. Okay, thank you, constructor. Bob died. Thank you, game. New guy was born. Thank you, game. Wait a minute. What happened to new guy? Now we've come back outside of the call, back into main. Bob's health is negative 75. Where'd the new guy go? Well, the garbage collector came in and took care of him. We lost our association to this guy because what we did was passed by value. Okay? That means that when we called damage, when we sent player, we sent a copy of the reference, a copy of this address went down here. So now we have a copy of the address.
And then with that address, we were able to change the health.
We changed the health, so all that, we changed the health to a negative 75, so that worked great. Then we ended up in here. Now we came up with a new address pointing to a new object, and we put it in this. But this it just received a copy, that's all. It's not a reference. So since it's just a copy, that's cool. Got a new object. All is good. We hit the end of our method call and forget about it. We come back up to here, and when we come back up and continue on down here, we're still pointing at the original guy. That is the key thing to understand here. So the way to fix, let's go and fix it to wrap this up, Logan. Let's go ahead and put, back up there. Let's put ref in and put ref back in down there. We have to pass by reference here for this to work properly. Bob was born, Bob died, new guy was born, new guy's health is 100. Logan, anything you want to add to this?
Nothing other than that if the rest of the inner workings of these two classes is a little bit fuzzy, that's okay. The one key thing to remember here is the difference between calling damage and passing player by reference, in which case you can change this actual address held by player. So that means player after this line, this player could point to something other than Bob. Whereas if you pass by value, this player is always going to point at Bob. Even if we do other things and create other game items, when passing by value, that means that we're going to copy this off, and then outside we keep player as the same value. So again, the key difference there is that passing a reference type can indeed be passed both by value and by reference.
Very cool. And the neat thing about all of this, Logan, on top of all this, on top of ref, is them getting to see, really for the first time, us passing an instance of a class to a method, which is good stuff, because we're going to be doing that a lot. Okay, so let's go ahead and jump back over to the whiteboard. Woo! So that was looking at ref. So we've stepped back from out, looked at ref, showing you passing a reference type by value and passing a reference type by reference. So be very careful when you start talking about reference types and value types. They're different than passing by reference and passing by value. So hopefully at this point you have a bit of an understanding as to the difference of passing by value and passing by reference. All right, so let's go ahead and come over here. Let's turn this page off. Come all the way back down. At this point, we've taken a look at parameter passing by value and by reference. And this brings us to the final thing I'd like to demonstrate, which is method overloading. Very, very important here. This is where we can have methods. Well, hang on. Okay, I just don't feel right unless I have a whiteboard. So let's come up here, add a quick whiteboard. Yeah, now I feel better. Method overloading. That is a G on the end, I promise. Alright, so method overloading is when you have two or more methods that have the same name, but their signatures are different, and they exist within the same scope. So if I had, well, here's a really good example. Watch this. So if we had static, well, hang on, not that. There we go. Static, void, main, blah. And then inside here, we had int A equals 5, int B equals 12. And then I wanted to write out the area is, Logan, what is the area of a square?
That would be that side times itself.
Okay, so that side squared.
Or you could even say side by side, but because it's a square, that means all sides are going to be equal.
Right.
So you could say side times side. Well, yeah, side times side, and sides are all known. So just whatever value times itself.
So times itself. So in that particular case, we're working with a single value. What if you had a rectangle?
Well, then you have a width and a height that can differ. So it has to be width times height.
You got it. So here's a situation where we could have two methods for calculating area differently. So let's have a method called calculate area. And let's start out by just passing A. So we're going to pretend that we have a perfect square. So now down here, I'm going to create a static int calculate area, and it is expecting a single argument. And inside here, what we're going to do is a return A times A, as Logan was saying just a second ago. And now and this will work just fine, okay? Because we can go ahead and call calculate, and we can pass A down to it, which is 5. So 5 comes into A, and 5 times 5 gives us 25, and then we get printed out area is 25. But now what if I wanted to say we had a rectangle whose side was A and B, 5 and 12, so two different numbers. So watch this. Here's method overloading. Static int calculate area. So the exact same name, but here's the key. A different signature. So calculate area taking in int, heck, we can call it width and height, as Logan said a second ago. And it is going to return width times height. Very good. Now, it's quite simple. The compiler is going to know which method you're calling upon based off the signature. How many parameters are we sending, and of what type are they? Well, we're sending one parameter that is an integer. So the compiler is going to say, well, he's got to be calling this one. But if I came in here and did this, A, comma, B, terminator, the compiler would say he's sending two arguments, both of type integer. So let's scan through the method table. Is the first, nope, wrong one. And let's take a look at the second. Ooh, the second one has two integers. Perfect. That's what we're looking for. So that is the method that we're going to call.
Yeah, makes sense.
Okay, I thought you wanted to add something. All right, so that's what method overloading is. Let's go ahead and create this example for him real quick, Logan.
Okay, so once again, let me start a new project, discard the old one, and make a new console application.
Okay.
Now, let's define our variables first. Let's have an int a equal to 5, and an int b equal to 12. Now, let's jump down and write out, so let's grab our console, do a write line, where we write out area is, and then we'll concatenate onto that calculate area for A. So, let's see, calculate area, and we'll simply feed it A to go with the first example. And before we get any further, let me also do a read line so that we can just check the output after we run it.
Sure.
All right.
Now, let's go ahead and create our two methods. And inside here, I want you to do me a write line, if you don't mind, inside each one. That can say, in first calculate area, and the other one could say inside, second calculate area.
Sure. So for the first one, we're only specifying one integer, so let's simply call that parameter A. And inside of this version of calculate area, we'll do a console write line to indicate which one we're in. So console write line.
In first calculate area.
In first, we'll say square. In first, calculate area.
Okay. Beautiful.
And then of course, we want to return A times A. All right.
All right. Now let's just, if you want to copy the whole thing.
Sounds good to me. We'll copy, paste in a second version. This version of calculate area, or this overload of calculate area, is going to take in two integers, an int for width and an int for height. And instead of here, we want to change this to in second. So dyslexia there.
That was awesome. Okay.
So in second calculate area, where we return width times height. All right.
And the key thing, as you just heard Logan said, in this second overloaded method, so Logan is now overloading the method by coming in and creating a different parameter signature there. Okay? All right, so now that you have that in place, the compiler is going to know all the way back up here that which one we're going to call on because of our parameter list. So let's go ahead and build and...
As a matter of fact, before I build, let me finish off the parenthesis for the write line.
Good idea.
So if we build, now everything is happy, except for not using B, which isn't a problem.
So it should get 25, because 5 times 5 is 25. And in first calculate area is 25. Very good, and no errors or anything, so let's go ahead and close that. Now just put comma B. Oh, even better, you're right there. Ooh, back up. This is too good. Back up and do the comma.
Oh, I see.
Ladies and gentlemen, you've seen this so many times now as we've worked through the Hyperion project and Canon 1, 2, and 3.
Especially with console.writeLine itself.
Oh, yeah, exactly. So check it out. Now you can see that there are two implementations of calculate area within the scope that we're working. And here's the two implementations we have. They basically take two different sets of parameters, an integer, and then if Logan hits the down arrow, an integer and an integer. So we can use this to determine, just to walk through and look at the different overloaded methods that you have to choose from.
Right, we can see the two overloads of calculate area reflected in IntelliSense.
Exactly. So go ahead and put in B. All right, and now if we were to run this, in second calculation, area is 60 because 5 times 12 is 60. Very cool. So once again, the compiler is smart enough to know which of the two methods to call on based on your formal parameter list. It's that simple.
Another interesting thing to point out is that unlike in cases where we were working with new and having to worry about things like hiding a method, this is different. We're not hiding, we're overloading, because when we redefine calculate area a second time, we specify a different argument signature, which means that this calculate area isn't going to hide this one.
Right.
It's going to overload it by adding another method which takes in two integers.
And right now, as a beginner, you might be thinking to yourself, why would I ever want to do this? You'd be surprised at how often you want to do this. Like Logan said just a second ago, do console.writeLine.
Let's just jump back up and anywhere and do a console right line. And check it out.
19.
Overload 1 of 19.
Yeah, so as Logan scrolls down, so you can write out a bool value, a char value. The list just goes on and on and on and on and on. So you'll notice that basically all of these right line methods have all been re-implemented basically with these types of parameters, dealing with this kind of data coming in.
So it actually makes WriteLine feel a lot more friendly because you can, without even thinking about it, throw an integer at it.
Exactly.
Throw a float at it. Throw a string at it.
And it just handles it, and you don't have to worry about it. So overloading is going to become very important very quickly. Okay, so with that, now there were a lot of concepts that have been introduced here. To wrap up overloading, just remember, the key thing here is the method signature. The names are the same, but it is our parameter list that's changing. Compiler doesn't care about the names. The compiler only cares about name and number of and type of parameters. And remember, all the way back to the very beginning, that was our method signature. So let's go ahead and, just for fun, ooh, look at all this. It's going to look like some type of really crazy math problem. Yeah. So surely it has been over an hour now that we've been going through all this stuff. Yeah, that's awesome. So hopefully you guys have picked up a lot. Let's go ahead and bounce all the way back to the beginning. Wow, there's just so much stuff. Okay, so all the way back down here to the beginning. As I said, the method signature. And remember, the method signature, this is all the compiler needs to know about. The name to look it up, and then it needs to basically just look for how many parameters are you sending, and what types are they. Doesn't care about the names. How many, what types. And it gets all of this from the method signature. Okay, so that takes care of method overloading. And that takes care of this video. So we started out real simple, explaining what a method was. From there we moved down into syntax, and we saw syntax divided up into two different kinds of syntax. We had the syntax, which is the syntax for the method, and then we had the syntax for the parameters. So we talked about them. From there we then talked about method calling, and we took a stroll through memory lane. We saw what happened in a very generic sense on the stack when dealing with methods and method calls and local variables. From there, we introduced you to some common terminology, method terminology. We talked about method headers, method signatures, and argument signatures. From there, we went over all the access modifiers, and then we talked about all of the other modifier types, things such as virtual, overload, abstract, sealed, extern. We then started talking about parameter passing, but we got a little bit more specific. We talked about when passing parameters, there's two ways to go about it, by value and by reference. And we introduced you to the ref modifier for the parameter, and we introduced you to the out modifier for the parameter. And then we wrapped everything up by taking a look at method overloading, which is the ability of having multiple methods with the same name within the same scope, meaning like in the same class, with different parameter signatures or argument signatures. Okay? So with that, Logan, is there anything else you want to add to this?
No, I think that covers it.
Okay. Well, ladies and gentlemen, that is going to wrap up this video covering class members' methods. Thanks a lot.